Arrange these fractions from least to greatest. All right, so to do that, we are going to have common denominators on all of them. And if I look at 4, 2, 12, they all have a common denominator, and I'm going to go with 12. This one's already done, 5/12. This one is going to be 0/12. This one, if I change this to a 12 by multiplying by 6, I have to multiply the top by 6, and that gives me 6/12. And if I make this one 12 by multiplying by 3 on the bottom, then multiply by 3 on the top, that gives me 9/12. And this one is a negative, and we have to multiply by 3 to get to the 12, which means we have to multiply the top by 3, which gives me negative 9/12. If I'm going from least to greatest, obviously my least is going to be my negative number, so I need to write negative 3/4. This one, the 9/12, so we're done with that one. I want to scribble it out so I know I'm done with it. Now I need to figure out which one is the least here, 9, 6, 0, or 5. Well, to me, I think 0. And I'm done with that one. Oops, sorry, that should have just been listed as 0. 0. Now 5, 6, or 9. 5 is the smallest, so I label it as 5/12. Noticing I'm labeling in my answer the original numbers, even though I made equivalent ones to be able to compare. Now 6 or 9. 6 is smaller, so I'm going to list my 1/2. And then 9 is my biggest, which is 3/4. And I'm done with that one. Decide whether each pair of fractions is equivalent or not equivalent. Justify your reasoning. Okay? So we have negative 2/3 and 2/3. Okay, so if we look on a number line, here is negative 2/3 and here is 2/3. These are not equivalent. You could show this and say not equivalent because they're on the opposite side of 0 from each other, something along those lines. All right, on this one, you could reduce both of these. They're both reducible, and if you reduced 3/6 by 3, you would end up with negative 1/2. And if you reduced negative 4/8 by 4, you ended up with negative 1/2. And you would say equivalent because they're both equal to negative 1/2, something along those lines. So now we have 8/5 and 1 3/5. So if you notice, this one is an improper fraction, which means it's equal to some kind of mixed number. So we need to figure out what that mixed number is, or we can transition this mixed number into an improper fraction. Whichever way you're more comfortable with is fine with me. I'm going to go ahead and change this back into an improper fraction and see if they are the same. So to change a mixed number, 1 3/5, into an improper fraction, I multiply 5 times 1 is 5, plus 3 is 8, and my denominator stays the same. So now I can see that 1 3/5 is equal to 8/5, which is the other fraction. So you could say, yes, these are equivalent because they're both equal to 8/5. Or if you did it the other way and you turned this into a mixed number and found out it was 1 3/5, then you would say, yes, they're equivalent because they're both equal to 1 3/5. Again, making sure that you show your work. I realized after making the video that number 8, while it showed on my phone, once I converted it to iMovie, you could not see me while I was explaining number 8. So I'm putting this back in there. So it says, I have 20 different kinds of Beanie Babies. I noticed that 4 of them are not animals. So I've circled and underlined all my important information. It says, what is the ratio of animal Beanie Babies to non-animal Beanie Babies? So underneath Beanie Babies, I put 20. And underneath non-animal Beanie Babies, I put the 4. So I have 20 to 4, which I could then make a unit rate. Remember, unit rate means one of them has to be a 1. And so I reduced the 20 divided by 4 and got 5, and 4 divided by 4 and got 1. So my unit rate would be 5 to 1. All right, number 9. How many fourths are in negative 4 and 1/4? Justify your reasoning. Okay, so if 4/4 equals 1, okay, so I'm just going to look at this as just 4 1/4 because it doesn't really matter that it's a negative. I need to have 4, so I'm going to do that. If I did that 4 times, okay, here's 1, 2, 3, 4, so here's your 4. I would say, well, there's 4, 8, 12, 16 fourths just in the 4, and then I've got another 4th here. So that gives me a total of 17 fourths. How many fifths are in 2 2/10? Justify your reasoning. So the kids have learned how to transition this to a fraction. So we have 2 2/10. And if I reduce 2/10 by 2, I end up with 2 1/5. So now I got to figure out how many total fifths are here. Well, it takes 5 fifths to make 1, and another 5 fifths to make another 1. So that gives you your 2. So for the 2, you have 10 fifths, plus you have an additional fifth here, and that gives you a total of 11 fifths. Sorry, my writing's messy. I'm trying to work around the stand holding my phone. Write each fraction as a decimal. Okay, so we have -3 4/10, -3, and this first place past the decimal is called the 10ths place, and we have a 4, so we're going to stick a 4 in the 10ths place, and your answer is -3.4. This one says 4/6. This one's a little more difficult. However, we can reduce this. There's 2 ways to solve this. You could reduce this by 2 and realize this is 2/3, which is one of the decimals I've asked you to memorize, which is 0.66 repeating. The other way is you could have divided 4 divided by 6. 4 goes in the house, 6 goes outside of the house, divided it out, it would have given you the same answer. Number 11, write each decimal as a fraction. So again, negative, so I want to put that there first before I forget. And this is 4/10 because it's in the 10ths place, and I can just write 4/10. I can then reduce that by 2, and that gives me -2/5. This one, the 8 is in the 10ths hundredths place, so I know when I make my fraction, I'm going to put the 8 over 100 because it's in the hundredths place. And then I can say, oh, I can divide by 4 each of these, and that gives me 2/25. I hope this video was helpful. Know that there are more than one way to answer many of these questions, and I have gone over the ones that I feel like the students use the most, but if you do have questions, please see me before the test. Thanks.